This time, I'm here to explain about the question. What is the behavior of the polynomial f of x equals x to the power 4, negative 5x squared plus 4? To solve this question, you need to know what the polynomial is. If you have no idea about polynomial, please check out my previous video first. So let's get started. So in this question, you need to know how the graph of polynomial look like. You don't need to sketch it properly, but at least you need to know both ends, this one and this one. I mean, when x is really big, how is y value going to be? And also, when x is really small, how y value is going to be. So when graph goes right, it might fall, it might rises, and it might falls, and it might have a constant number. So you need to find out how does the graph, how does the end going to be. This is the end behavior of the polynomial. So let's find it. So like I said, you have to find the both ends. So when x is really big or really negative, so first let's find the really big one. When you plug in x equals 10, how the y value is going to be? It's gonna be 10 to the power 4, 10,000 negative 500 plus 4. I explain about why I don't calculate it. The next one, I want to plug in 100, and it's gonna be 2, 3, 4, 5, 6, 7, 8, and 5, 1, 2, 3, 4 plus 4. Okay, then what about when x equals 1000? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5, 1, 2, 3, 4, 5, 6 plus 4. So when x value is really big, how is y value? It's also so big too. I don't want to count it, but obviously it's so big. So you can write to rises, graph rises to the right. Okay, then let's also find out when x is really small, negative 2. It's gonna be 1, 2, 3, 4, negative 500. It's same because the exponent is even number. So yeah, 3, 4, 5, 6, 7, 8, negative 5, 1, 2, 3, 4 plus 4. And next one, 1000, negative 1000. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, negative 5, 1, 2, 3, 4, 5, 6 plus 4. And when x is really small, y value is also really big again. So rises to the left. Oops. This is the answer. But did you notice that actually I plug in x value in f of x, but obviously you didn't need to plug in here, and this value doesn't affect the whole value of f of x. So what I wanted to say is, if you want to know the end behavior of the polynomial, you just need to know, just plug in the one with highest degree. Okay, then let me give you another example. f of x equals x to the power of 5, negative 5x to the power of 3, plus 2x plus 1. What is end behavior of this polynomial? Like I said, you need to focus on the one which has the highest degree, the highest number of exponent, which is x to the power of 5 in this polynomial. And you can ignore rest of terms. And when you find in the behavior, what you have to do is plug in really big number or really small number. So let me plug in x equals 1000 in x of x to the power of 5. It's obviously it's going to be pretty big, extremely big. So you can say graph rises to the right. And what about when x is really negative? So it's power of 5. So the answer is going to be negative, but it's also going to be pretty big. So it's really big negative. This means it's falls to the left. So again, you need to focus on the one with highest degree. You can ignore rest of the terms.